Hi all. In our first video, we have gone through the column store indexes and its purpose, how the data are stored in our SQL Server pages, and a sample example with a regular cluster index and a column store non-cluster index. Now we will see the benefits with non-clustered, benefits with column. Here the benefits are: each page stores data only on basis of column, so that gives significant improve in performance when fetching selected columns from a table. And as we are reading a single column data, and that too reading very less number of pages, nothing but a single page, and one page one column data increase the chances of high percentage of data compression because of the similar data type and data for same column, and does not physically stores columns in a stored order. Instead, it stores data to improve compression and performance. And a column store index by default compresses the data by new column store compression methodology. And here we have few restrictions to the column store index in 2012. So those are: column store index cannot be combined with other index types, and we can use only non-clustered column store index in 2012, and only clustered column index are updatable. On the other side, non-clustered column store indexes are read only. And in our SQL Server 2012, we have only non-clustered column store index, and we can't create clustered column store index. And non-clustered column store index requires extra space for columns and to copy the index. And other criteria is it takes more time than 1.5 times almost than creating a B-tree index on the same set of columns because the data is compressed here. And here a table can have only a one column store index, and hence you should consider including all columns or at least all those frequently used columns of the table in the index. This is in 2012. And column store index can only be non-clustered and non-unique index. You cannot specify ascending or descending order or include classes in non-clustered column store index. And it's not for all the data types. We can't include the columns with the data types binary, var binary, text and text, varchar max, and other etc columns. And the definition of the column store index cannot be changed with the alter index command. We need to drop the index and recreate the index. And we cannot create a column store indexes on view. So there are all limitations in 2012. Nothing but a table can only have a single non-clustered column store index. Once we create non-clustered column store index, the table will goes into non-updatable mode. Means we can't do any DML operations on the table once we have non-clustered column store index in 2012 SQL Server. And the other things are a single non-clustered column store index will be allowed in 2012, and it uses a segment compression for high compression of columnar data. And when we come to the SQL Server 2014, it supports column store clustered index. It is one extra feature that we have in 2014. And in 2012, once we have a column store index, it goes to read-only mode. But in 2014, it allows updatable column store index when we have clustered column store index. And the delta stores are used with clustered column store index only to gain the performance. And so as I said, in 2014 with clustered column store index, a table can be in updated mode, like we can perform insert, update and delete operations. And both clustered column store and non-clustered column store index has new archival compression options, that is column store archive, to further compress the data. This is a new feature we have in 2014. And coming to the 2016, where we have few new set of features, where a table still can have one non-clustered column store index as well as one clustered column store index. Here this will be updatable index. But whereas in earlier versions, it can't be updatable with non-clustered column store index. And here we can create filtered non-clustered column store index by specifying a where class to it. And other thing is, a clustered column store index can have one or more non-clustered row store indexes. So this is a new feature again we have in 2016, where we do not have this in 2014 and 2012. And other thing is, so a clustered column store index can now be unique indirectly, as you can create a primary key constraint and a heap table and also a foreign key constraints. And other thing is, in 2014 we do not have a facility for the column store index with the B tree search. I mean, we can't do B tree search for our data, where this facility is available in clustered row store cluster indexes in our row store mechanism. But in 2016, with clustered column store index and other index that we can create and maintain B tree search mechanism for the fast data retrieval operation. So these are the new features that we have in our 2016 clustered column store index. And other thing is, it supports in-memory tables, as you can create one column store index on top of them. So these are all the new features when we compare to 2012, 14 and 16. By looking into all these things, 2016 has the best features than 2012 and 2014 for column store index, where we can perform all operations and we can create any number of non-clustered indexes when we have clustered column store index, and we can perform B tree search on the data, and we can have foreign key and primary key constraints to avoid data corruptions in our systems, where we do not have this feature in our 2012, where we can't create any constraints on our column store index. So in one thing, in 2014, if we have a non-clustered column store index, we can't create any other non-clustered column store index, because this 2014 in clustered column store index should include all the columns in a table, and the data will be stored in a columnar manner. So that's why we don't need to create any other non-clustered column store indexes. But it's different in 16. So these are the details about clustered column store indexes and its features and differences in 2012, 14 and 16 versions. Thank you.